So we also have the indirect method, okay, which means you convert one process variable, there is another process variable, you convert it to level. And a very notable variable that we can convert to level is pressure. Okay, remember, in a vessel, the pressure that the vessel exerts at the base of the vessel is dependent on the height of that fluid in the vessel. Okay, that is, pressure is equal to rho GH. Okay, where rho is the density of the fluid in the vessel, then G acceleration due to gravity, and H is the height. So since the rho and G, they are constant, as H is varying, what will happen to the pressure? It will be varying, and H is the height or level of the fluid in the tank. So as the pressure is increasing, that shows that at the base, the pressure is increasing, that shows that level or height is increasing. As it's reducing, that shows that level or height is reducing. So by measuring the pressure at the base, okay, we can use it to infer that is, deduce the level of fluid in the tank. So this is a DP, differential pressure transmitter. Okay, so one end is subjected to high pressure at the base, and the other end is subjected to low pressure at the upper part of the tank. So whatever that is given off from the transmitter is directly proportional to the difference that is here. So as the height is, if the level of the fluid in the tank is high, you see that the differential pressure will be high, because the HP side will be high and the LP side, which is almost constant. Then as the level is going down, HP side will be coming down. Okay, so the signal that will be given off will be dependent on the level or height of the liquid in the vessel. So that is the indirect sensing. That is, we are using pressure now to infer the level of the fluid in our vessel or in our process. So this is an example of the installation of a level gauge, okay, using differential pressure transmitter. Are we getting it? So whatever that is sent off this, okay, wherever it will be read off, okay, on the indicator here, it has been calibrated to give us a direct level reading of the fluid in the vessel. Okay, so we also have other types of level sensor, which is the ultrasonic level detector. In the ultrasonic level detector, we have a transmitter and receiver in one detector. Okay, so an ultrasound is emitted. When we say ultrasound, we mean sound that is beyond the human hearing range. So that is the kind of sound that is transmitted. So it actually travels with the speed of sound. Okay, so as it goes into the vessel, on the surface of the fluid in the vessel, it is reflected back to the transmitter, the sensor within the transmitter. Remember, it is that is the sensor within the level measuring instrument. Remember, we have a transmitter and a sensor. So the transmitter transmits the ultrasonic wave, so it is reflected back. Okay, so the time it's used to travel gives an indication of the level of the fluid in the vessel. So if the travel time is short, it means that the fluid is the level of the fluid is high within the vessel. Okay, that means the vessel is full. That is why the time it took the ultrasonic signal to go to the level and back is short. But once it's a little bit empty or is low, you see that it will take a longer time to travel to that surface and back. Okay, so that travel time, which will be deduced by the measurement device, okay, is calibrated to give us a direct reading of the level within the vessel. So you can see how it is physically installed on the process. Okay, so as it is emitted, it goes to the liquid surface. I guess this is water. It is reflected back. Okay, and then the time of travel indicates the level to which the water is in that container or in that reservoir. Okay, so this is it. The transmitter emits the ultrasonic sound. It is reflected on the surface of the fluid, sent back. The transmitter emits the ultrasonic sound. It is reflected at the surface of the fluid, sent back. So the travel time gives us this the level of fluid, okay, in the tank. So this is how they are physically installed. This is the one that is physically installed in a vessel. Okay, this is an open tank. This is a closed vessel. Are we getting it? So you see the time delay between the transmitted pulse and the received pulse. So this time delay is an indication of the height of the fluid. So we also have the capacitive level detector. So in the capacitive level detector, they are usually mainly used in conductive, that is to determine the level of conductive fluids in a vessel. Okay, so the fluid will now form the electrolyte, okay, within the vessel. So we know that as the electrolyte concentration is increasing, the capacitance will do what? Will also increase. And as the height is increasing the concentration of that electrolyte between these electrodes, okay, that is now helping to form a capacitive cell. So that capacitance will now be what will be detected and calibrated to give us a direct reading of the level of the fluid in the vessel. So here is an electrode. In this case, since we have single electrode, the body of the tank is used, okay, as one of the electrode. So the principle remains the same.